So I heard this statistic joke. No, I'm just kidding. I don't have any jokes. I'm not a joker. I don't know any jokes. But I do know we are on day 1. And we are on day 1. Day 0 was yesterday, but that was your first foray into becoming a discerning statistician. So you don't get the wool pulled over your eyes and get fooled by everybody else that can say, 29% of the population in America loves goat tail. What? What does that mean? I don't even know what that means. Who did you? I don't even know what goat tail is. I don't even know where I came up with that. But whatever. All of this information can be found at NK Infinity and beyond. Hey, look. If you haven't hit the subscribe button, you're going to want to do so. We're getting close to the end. Got lots and lots of review coming, and you're going to want to be on the front end of getting that review material. My name is Mr. Krause. For today, I'll be called Mr. Key. By the way, the N stands for Newman. The K stands for Krause. We are, in fact, NK Infinity. There's my partner in crime. I don't know why she's not behind the camera. Clearly, she's better looking than I am with my bald head. But it's my basement studio, and I guess she'd have to spend a lot of time in my basement. And who the heck would want to do that? Maybe I'll take a picture someday in my basement, and you'll be like, not a place I want to visit. Guys, if you're not creeped out by the time you're done with this unit, you will be. By the way, just in case you're wondering. Those of you that watch my videos on a regular basis, how many cups of Dunkin' Donuts coffee have you seen me drink? You grab a little K-cup, throw it in the machine, drink, and then you're like, ooh, Dunkin' Donuts coffee. Anyway, let's get started. We talked a little bit about stuff yesterday, and we want to know, why is it important to obtain a random sample from a population when conducting a statistical study? I'm not looking for a paragraph here. You know what I'm looking for? You want to make sure everyone is fairly represented. You want to, random, what you need to really remember, random equals well-collected data. Generally, when someone says they have a random sample and there's somebody that's reputable, they've collected the data using good statistical sampling techniques. They're not lazy. They didn't do lazy ones. They did what was that one? Convenience data. Garbage. And the other thing we want to do is, once it's corrected, it minimizes bias. Minimizes bias. And bias is bad, 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 bad. All right. Let's read through this study. In 1936, the Literary Digest had correctly predicted the last 3 presidential elections and went to predict the winner of the contest between Alf Landon and the Republican, I don't know why Republicans are capitalized, and Democrat Franklin Roosevelt. The magazine sent ballots to 10 million citizens. The result ran strongly in favor of Landon. Leading the Literary Digest predict a win to win the election. Yeah, clearly reading's not my second language. What? About 25% of the ballots were returned. So that's, let's see, of 10 million, that's 2.5 million ballots were returned. Now this newcomer, George Gallup, have anybody heard of the Gallup polls? Was working on a sample size of was 1,000 times smaller than the Literary Digest. Let's see, take a 10,000, subtract off 3 zeros. Let's see, 10 million. Get 1,000 times smaller. So he only had 10,000 people he was talking to. He only had 10,000. However, the Gallup predicted a victory for Roosevelt. Should the Literary Digest have been able to give a more accurate prediction? Anybody heard of President Landon? I don't think so. Explain why or why not. So the question is, should they have been able to give a more accurate prediction? Maybe. But I'm going to say no, they would not. No, they would not. How about they would not? That sounds like a double negative. I want to be careful with that. How about we just say they would not have been able to. They should not. How about they should not? They should not have been able to because, and here's the big cause, their sample was not random. We had all kinds of bias going on here. We had all kinds of bias. The first thing they did wrong was they sent it to all their subscribers. Well, who subscribes to the Literary Digest? I don't know. I'm going to guess a whole lot of Republicans subscribe to the Literary Digest. So I'm not sure what they all have in common, but my guess is a lot of Republicans subscribe to the Literary Digest. Literary Digest. Therefore, you have like an undercoverage bias. We have an undercoverage bias, which means we're only asking Republicans who they're going to vote for, basically. At least in this case, maybe they have other factors in common, but if they're all saying they're going to vote for Landon, then my guess is there probably a lot of them are Republicans. Here's the other thing. They also have non-response bias, right? Non-response bias. You know, maybe a whole bunch of people didn't respond. Maybe all the Democrats didn't respond. I don't know. Whereas Gallup must have, since he got a better answer, Gallup must have been using random sampling. And therefore, he predicted Franklin Roosevelt, and of course, Franklin Roosevelt won. So here's the thing you have to be careful of. You know, if Time Magazine asked who the Person of the Year award should go to, they might get answers like, what's her name? Kim Kardashian. What? Person of the Year? But if you ask people that read like Time Magazine or something like that, you might get somebody that's in the political realm, or you might get somebody that's in the, if you ask people that watch Science Weekly, they might pick. You have to be so careful that you pick a random group of people. So a simple random sample, a simple random sample, SRS, a simple random sample. I'm not sure where the simple got off. Somehow it got deleted. It was here. It's on my notes. Every combination of size n has the same chance of being selected. Has the same chance of being selected. A simple random sample just basically says everybody and every group and every combination of whatever size has the same chance of being selected. There's a couple different ways you can get random samples. One way is what's called a random number table. We're going to talk about what that means in a couple of minutes. But basically, you assign numbers to the population if they are not already numeric. So, if you wanted to figure out what the most popular name is in America, you might give everybody a number, but well, actually that would be just collecting data. Randomly determine a starting point. So randomly, I'm going to try to write neater. Determine a starting point. The thing is, I'm pretty neat when writing normally. You guys would not agree with me, but when I do my normal handwriting, it's pretty neat. Follow the string digits. Follow the string of digits no skipping. Now, some of that's not going to make much sense until I go through an example, and then you're like, oh, that's easy, I got it. Draw from a hat, same thing, you're going to assign numbers. Again, we want to try to make it fair and random. Assign numbers to the population. Place them in a hat. And draw out sample. And the big thing about this one is don't replace. Don't put them back in. And finally, a random number generator. And you assign numbers. Again, you assign numbers to the population. And we're going to do all of these. Well, we're not going to do the hat because that's kind of impossible. Assign numbers to the population. And use rand int. This is the function low high. You'll see in a minute what I mean by this too. Low high on our calculator to get this, to get the number, to select your sample, to select sample. Now, those of you that take computer science are going to understand a little bit well what I'm about to talk about. For those of you that don't understand about computer science, especially with this random number generator thing, those of you that don't take computer science may not understand this, but there's not a lot in the world that's random, and it's really difficult to get the computer to think of a random number generator and something that's random. How am I going to say this? A computer only deals with very discrete stuff. You give it a number, it does something. Like, let's say I give it the number 10. Well, it says maybe it'll take 10, divide by 5, multiply by 3, take the square root, cube it, and then take the 2/3 power. And boom, and then we want the third digit. There's a lot of steps, like 12 steps I just said probably, right? All those steps I just said, square roots, blah, 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 to get, and then I said take the third digit. And that's when I gave it 10. Well, if I give it 10 to start, and it does all those series of steps, because a calculator or a computer can only do certain steps. It only does steps, right? It's always going to arrive at the same number. If you take 10 and you divide by 2, you get 5. If you square that, you get 25. You take the cube root of that, you get, I don't know, 3 point something. No, 2 point something. And then if you cube that, and you square root it, and you take the 2/3, and then you get some long decimal, and the third number will always be the same, no matter what. And then if you give it 15 to start, well, whatever that third digit is will always be the same. So the starting value has to change always. Well, to get a computer to change the starting value, you have to ask the user, I guess, and then they can create a random number generator. But but unfortunately, that entire set of numbers will always be the same set of numbers. So if somebody picks 10, and then the third digit is 3, and then they use that number to find the next number, but that number will be 5, and the next number. So it'll always be that same sequence of numbers. I know I'm boring some of you, but this is kind of cool. So the only way to legitimately always have random numbers is to use the one thing in life that is completely random and not repeatable. Does anybody know what is completely random and not repeatable? Completely random. Right now. Boom, boom. Random. That was random. It'll never happen again. There, I did it again. That snap will never happen again. Anybody know? The answer is time. Time is the only thing that's completely random. Right now, it is July 30th, 2016, and it is 12:56 and some seconds time in the afternoon. Oh, that time just left. Oh, that time will never that time will never happen again. None of those times will ever happen again. So I can use the 7/30/2016. I just screwed that up. 2016. So I can use the time 7/30/2016, 12:05/6 and 23 seconds. Boom. That number will never happen again in time. And that's what's truly random. So that's how good programmers choose random numbers. For those of you taking programming, remember that. It's kind of cool. All right, let's get started then. Let's start right with our random number table. But okay, here we go. So farmer Nathan Savage at some Sunscape Farms wants to know the average yield of his zucchini plants. Now, zucchini plants or average yield, zucchini plants or parts of his land don't have numbers associated with them. So instead of recording the data for hundreds of zucchini plants, he decides to take a random sample. So I guess he could go around and count all of the plants on every plot of land. But let's say this is, 100 acres by 100 acres. That's 10,000 acres of land. Nobody's going to do that. They might just want to say, I'm going to take, I'm going to take random numbers. I just want to take a few random numbers, and I'll figure out what those are. So we're going to do a random sample, and we're going to a sample of 15 zucchini plants, or 15 plots where zucchini plants are. Maybe there's only one zucchini plant in there, maybe there's two, but we're going to take each plant, we're going to figure out what its yield is to figure out what the overall average yield is. So here's what he did. He numbered his land. This is his land. He numbered it across by 10 and down by 10. So now there are 100 areas in his land. I don't know how he did it, but he just did it. And this, if he had collected every single piece of land, this is what he would have found. Now, it's not what he found, but we need this in order to do our math. What he would do was, let's say the random number said, hey, go check out plot 50. So he would walk over, oh, there's plot 50. Let me count. 1, 2, 3, 4, 5, 6. There's 6 zucchini. And then the next random number yielded 86. So he'd have to come over here to 86 and count those. Oh, there's only 2. Whatever the number is, right? So we're going to just give that information to you. So we're going to use this table. This table says, okay, if he went to plot 50, he would find that there were 5 zucchini. If he went to plot 86, there would be 2. Ooh, I got lucky there, 2. Whatever the numbers are. So I'm giving you that information. So the problem with it is we need to represent 100 plots of information. So how do I know? So what we're going to do is instead of assigning these 1, 2, 3, 4, 5, we're going to call this 01, 02, 03, 04, 05, 06, 07, 08, and 09. If we're going to go to 1,000, we'd have to go 00, And then this one here will be 0, 0. 0, 0 is going to represent 100. So let's say I was doing 1,000. I would go 0, 1 through 0, 0, 1 through 999, but number 1,000 would be 0, 0, 0. You're like, huh? You'll stay with me, stay with me, stay with me. So these should all be 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, and 0, 9. So because I have 2-digit numbers, now this here is an excerpt from a very long table. This might be an entire page of just numbers. We only took a small piece of it. We need 2 digits. And we got to remember 0, 0 represents 100. And I put that down here. So this is really 0, 0. So here's how it works. You can decide where you want to start. You just drop your paper, drop the pen. Normally I just start right here. I'm just going to start right here. And I'm going to pick the first 2 digits, 51. Remember, we're doing 15. Then I'm going to do the next 2, 58. 47. Don't skip 47. Oh, I screwed up on my own notes. 23. 5. Oh, 5. See how I had to pick 2 digits? If I just pick 0, what's 0? What's 0? 46. 62. 98. 25. 72. And it's really important that you kind of write these numbers down underneath here. 16. 67. You'll see why I'm doing this in a minute. See how they're coming with random numbers? 93. 98. 31. Now nothing repeated, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I don't think I had any repeating numbers. If, for example, one of these numbers repeated, like 67, you would cross it off. You don't count it twice. So now comes the tricky part. So now what you got to do is you got to come up and look in your table, and you got to say, okay, what was the yield of plot 51? 1. What was the yield of plot 58? Nothing. And we're going to add all these up. What was the yield of plot 47? 1. What was the yield of plot 23? 3. Do you see how I'm randomly selecting? I'm only going to do 15 out of the 100. So it's only 15%. 5. 5 had 5. 46. 4. Random numbers. 62. 11. Holy mackerel. 11. Plus 11. 98. Ooh, 9. 72. Wow. Now, see, I'm getting a lot of big numbers, but it is random. It is random. I'm not picking this. 10. 16. 12. Crazy. 67 is 9. It really is a lot of big numbers. Plus 9. Plus 93. 8. I mean, I did get a 0 in there and a 1. 8 plus 90. Oh, see, I got 98 twice. See how I got 98 twice? I can't use that one again. So by circling them, I realized, oh, so when I stopped at 31, I couldn't use this 98. I stopped at 31. I should have done 25. Gone one more. So plus 31. So that worked out good. 31 is a 0. Plus, and now we got to do 25, which is another 0. See how, even though there was a lot of high numbers, I also got a lot of zeros. So I got all those numbers. Now I want to find their average. I'm just going to divide by 15. So I go over to my calculator. Should have probably brought this way over here. All right, so I'm going to add all these up. 1 plus 0 plus 1 plus 3 plus 5 plus 4 plus 11 plus 9 plus 10 plus 12 plus 9 plus 8 plus 0 plus 0. Hopefully I got 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think I only got 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I only got 14 numbers. Why is that true? What happened over here? 1, 0, 1, 0, 1, 0, 1, 3, 5, 4, 11, 9, 10, 12, not. How many numbers do I have up here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8's the 12th. Oh, I need one more. So maybe I didn't go out far enough. So I need 22 as well. Let's go get 22. You got to be careful when you do this. 22 is 3. So I should have added 22, which is 3. Again, you got to just be careful you don't make a dumb mistake. Let's go over here. Plus 3. And you get enter. And you divide by 15. And we get our yield. Oops. I forgot this calculator needs a decimal sometimes. Of 5.1. So our yield is 5.6 repeating. So this average, when I divide by 15, is 5.06 repeating. That's our average. That's our average yield. Based on this sample, you know, if I'd done a bigger sample, or if I repeated this experiment a few times, I might get a different example. But in this case, I got 5.06 as my yield. Okay. Let's try it again. Now what we're going to do is we're going to use our random generator on our calculator. Now I don't know how TI represents random numbers, and I don't know how they create random numbers, but they do a pretty decent job. So I can go over to my calculator. Excuse me. I go to my calculator. Let me clear out all this crap. Now you have to write all this down. You go into menu, probability, random integer. And the first number has to be the low number, which is 1. And the second number has to be a high number, which is 100. So we'll pick random numbers between 1 and 100. And you just click enter. So 95. So I'm going to come over here and hit enter a few times. 95, 91, 15, 52. So come back. 95, 91, 15, 52, 41. All right, 41. I got that. Let's go. Keep going. Keep pressing enter. All you got to do is keep pressing enter. I already had the 41. So 74. 74, 5, 34, 121. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. I need 5 more. Back over here. 1, 2, 3, 4, 5. 80, 96, 23, 37. Isn't that weird? And 1. I got both 1 and 100. So now I need these numbers. Now you can go back and look at your chart. I'm going to hold my chart here. I don't want to have to flip back and forth. But if I went back to this same chart up here and pull those numbers off. Hopefully I don't have any repeaters. Do I need any repeater numbers? I don't think so. So let's go back. I'm going to just switch colors. 95. 95 is 5. 91 is 6. Remember, we're adding. 15 is 0. 52 is 3. 52 is 3. 41 is 0. 74 is 4. 5 is 5. 34 is 2. 100 is 6. 21 is 12. Big one there. 80. Where's 80? 80 is 6. 96 is 10. 23 was 3. 37 was 3. And 1 was 12. And I'm going to take all those numbers, average them up, divide by 15. So now I got to go back to my calculator. See if I can get as many on there as possible. I'll clear out this crap. So 5 plus 6 plus 0 plus 3 plus 0 plus 4 plus 5 plus 2 plus 6 plus 12 plus 6 plus 10 plus 3, 3, 12. 3 plus 3 plus, oops. 3 plus 3 plus 12. Let's see, is that 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Enter! And divide by 15. Now that's freaky, because this is going to be like really, really close to the other one. 5.13. So on this one, I got an average yield of 5.13 repeating. And the last one I got 5.06. Now the question is it going to be the same average? No, it absolutely is not going to be the same average. It's going to be slightly different. Now this case, it's really, really close, which is kind of weird. Maybe it is, maybe that's close to the true average. I don't know. But generally they will not be the same. Here, let me give you the last example, and this one you already figured out. Nathan's grandfather said, using that TI Inspire, that's just silly. Back in my day, we just drew numbers from a hat. So using and I'll do this one in class, we're going to collect 15 zucchini plants and determine the average yield. And will it be the same average as the other ones? No, not at all. Not one bit will it be the same. So those are just 3 different ways to do that. Let's move on. Other types of sampling. So let's go through some ways to do sampling. You can do a systematic sampling. I think we talked about this already. Start at a random point. Start at a random point and select using a system. Like, for example, every 5th person, or every 8th person. Someone asked me before, can I use every person wearing blue? Well, no, because now you've left out all people that hate blue. Now, do they actually hate blue? I don't know, but you've now interjected a bias, a blue bias. Now, is it going to be huge? I don't know. Maybe if you're talking about clothes, it might be, but I don't know. But you don't want to interject anything. That's why numbers are probably the easiest way to do it if you're doing a systematic sampling. A stratified sample is let me explain it, and then let me write it down and I'll explain it. You're going to first group the population. and then do a random sample within the population. And I'll show you what this means in a minute. And you can this allows me as the researcher to do comparative data. You know, let's say I asked, what is the average number of hours spent watching TV? And I asked everybody in the high school, and I think we talked about this before, and I asked the freshmen, and I asked the sophomores, and I asked the juniors, and I asked the seniors. I said, what's your average amount of time spent watching or playing video games or watching TV, whatever I just said? Well, it could be that I accidentally picked 90 kids from this group and only 10 kids from this group. So the math gets harder, you start to work, you got girlfriends, you got a car, and you want to go places. This one, you're stuck at home, you don't have a girlfriend, you don't have a job, the homework's easier, and your life's a little less exciting in 9th and 10th grade. So maybe you have less homework or less ideas. But when you start doing this and you start playing varsity sports and you start having more time commitments, you maybe have less time. But if I ended up with 90 sophomores and freshmen, it might say, hey, my God, kids in our school are watching 18 hours of television every week. But in reality, if you added in the entire good random sample, then you might get a better mix of people. And then you can compare, and then what I mean by comparative data, let's say I picked 25 from here, 25 from here, 25 from here, and 25 from here, and then took a random sample of that, and I said, oh, you know, take a random, I'm going to pick 25 freshmen randomly, I'm going to pick 25 sophomores randomly, I'm going to pick 25 juniors randomly and 25 seniors randomly, and then I'm going to find out what the average is. Well, that will give me a good mix. Each group of size n has the same probability of being picked. The other advantage is now I can say, hey, seniors on average watch 8 hours of television a week. Freshmen average 12 hours. So the freshmen are watching. So it allows me to do some comparative data. So when you think you might accidentally be leaving out a group using stratified strands, it might be a little bit easier. Convenience sampling. I, for some reason, feel like I just did this yesterday or the other day, yesterday with you guys. And this is just convenient data. Convenient. What's the chance of me actually spelling convenient right? Data. It's already exists. It's easy to get to. And most importantly, it's lousy. So the reason we talk about convenient sampling is, you know, if I wanted to find out whose people are voting for if I'm a researcher and I live in New York City and I want to find out who everybody's voting for president in November, or back in November when you're probably watching this, and I go out to, Central Park and I start asking people, who are you going to vote for? Who are you going to vote for? Who are you going to vote for? Well, I might get a different answer than if I ask some people in the Northeast and the Northwest and the South and the Midwest and Texas and Montana and and I might say, look, I got to ask 25 people from every state. Then you'd have a really good random sample, and you do stratification, and then you can say, okay, people in New York are going to vote more better than, whatever the number is. You might ask, even within New York City, you might ask Long Island people as opposed to, Harlem people, and they might be voting drastically different. I don't know. So anyway, let's do a systematic. Here's that same chart of Nathan's zucchini. And let's do a systematic approach and see how we do. So we're going to start, this should yield an example of 20 plots. So Nathan Zucchini arbitrarily selected a plot, record the number revealed, then record the number of zucchini for the 5th plot. So I am going to start. Did it tell me where to start? I thought I'd tell you where to start. We're going to start on, let's start on the 4th plot. I don't know. Let's start on the 4th plot. And I'm going to go every 5. 4, that's what, 9? Now I got to go to 9. And then, I'm going to go every 5th. Oh, so that'll make it easy. 14 and 19 and 24 and 29 and 34 and 39. Now this doesn't seem very random, but I'm still picking every 5. I started at 4. The starting at 4 was random, and I pick every 5. In this case, I'm going to get 20 numbers. Now, I'm not going to bore you and add all that stuff up. Well, I might have to because I don't have I didn't put the number in here. So I'm going to go to my calculator. I'll add all those up for you. It's 6 plus 4 plus 1 plus, 6 plus 4 plus 1 plus 2 plus 12 plus 4 plus 1 plus 4 plus 6 plus 4, man, a lot of 4s, plus 12 plus 7 plus 3 plus 12 plus 2 plus 0 plus 8 plus 5 plus 10 plus 6. Enter and divide by 20. And I got 5.95. So when I average those all up, I get an average of 5.95. That's slightly higher than the last time I did it. Last 2 times I did it, I got 5.04. But this time I took a few more numbers. Maybe this is slightly more accurate. I don't know. I'm not sure. It is an average. And when we start to talk about making inferences and making decisions and all that stuff in Unit 10, you'll see where we can say, okay, how confident are we that that's the actual average. When zucchini seeds are planted in early spring, farmer Nathan Savage had 5 people seeding his fields. Each person had 2 rows to tend to, 1 through 20, 21 through Nathan wants to make sure that each row was represented in his sample to account for variability in the seeding process. Randomly select 3 zucchini plots from each set of seeders. So, how am I going to do that? I don't know. Let's start with randomly select. So I'm going to say, now each seeder, we got seeder 1, seeder 2, seeder 3, seeder 4, and seeder 5. So let's start with 3 and pick every 4th. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Boom, done. And I got to add those up. That's a lot. I only wanted 3 from each, right? Isn't it what I asked for, every 3? So I'm going to use the numbers I came up with that I chose so that it matches my answer key. I randomly selected 1, 3, and 11. I randomly selected 23, 26, and 40. I randomly selected 41, 42, 41, 42, and 55. And then I randomly selected 67, 69, 67, 69, and 80. And 81, 93, 81, 93, and 97. So then I go back to this table over here. I circle all those up. Let me tell you what those numbers were. 12, 1, 12, 12 plus 1 plus 10 plus 3, 10 plus 3 plus 9 plus 12 plus 0 plus 1 plus 7 plus 9 plus 8 plus 6 plus 8 plus 6 plus 3 plus 8 plus 11. And it turns out there were 15 of them. And when I average these up, I got 6.667. Now notice I'm getting different numbers every time I do this. That's what happens when you do random sampling. You're not always going to get the exact amount, but sometimes the information you get is good enough. And sometimes you want it to be better, so you have to do more tests or ask more people. And we'll talk about standard deviation and spread later on. All right, so last open-ended response, and I decided not to do 1 through 10 because I forgot. I really wanted you to use the last row, which was the one closest to the house. It turns out row 91 through 100 is the closest to his house. So this, he doesn't have a lot of time. He's kind of, wait, what's going on here? Oops, I missed a page. Convenience sampling. Here I am. All right. So Farmer Nathan has busy here. He just decided he's going to do the one closest to his house. So he says, all right, I'm going to pick those, and he adds those up, and he goes 6 plus 12 plus 8 plus 4 plus 5 plus 10 plus 11 plus 9 plus 6 plus 6. Add those all up, divide by 10. You just pick the 10 closest to the house. Just pick the ones in that last row. Here we go. He's just going to pick these. These are closest to the house. Add those up and divide. So you ended up with 77 over 10, which is 7.7. Now that's the highest yet. And was this the best method? It was convenient. It was easy for him. But no, obviously it was not. Why was it not? Because it isn't random. Maybe the ones that are closest to the house, since we got the highest yield, maybe those get the perfect amount of sunlight. They got the perfect amount of water in the soil. How am I supposed to know that the ones next to the house, maybe those turned out to be the worst ones because they're next to the house and they get too much shade and not enough sunlight. So you have to create a random sample, otherwise you don't really get a good picture of what's going on. Just in a plot of land, just at your house, if you ever plotted things, depending on where they are in the light, depends on how well they might grow. And what can we do to change our sampling in order to get a better average? You can do a true simple random sample. Simple random sample. Just like we've done before, use an appropriate sampling techniques in order to get the proper sample. So let's just talk about these. I'm not going to write these down because, well, my handwriting's terrible. It says, explain the difference between a simple random sample and a stratified sample. Well, all right, I'll write them down. Stratified first breaks into groups. And then randomly selects from the group. And then randomly selects from the group. Simple random samples just start using sampling techniques and just start grabbing people. Stratified is going to break them up into small groups first and then randomly sample. Explain the difference between a simple random sample and a systematic sample. A simple random sample is subject is chosen randomly. In a systematic, so in a system, if it's a simple random sample, everybody has an equal shot. But in a systematic, even in a systematic, everybody has an equal shot depending, but you have a defined, let's say it's defined, that's the word I think I was looking for, a defined system to pick all the other people. right? If it was truly random, the first person could be picked, the second person could be picked, and the 8th person could be picked. But let's say I said my sample is going to start at 3 and I'm going to pick every 7. Well, there's a whole bunch of people there that aren't ever going to get picked and have no shot at ever being picked. A simple random sample would say I can pick those people. A systematic approach says I can only pick every 7, so the other people really have no shot at getting picked. Convenience sample is, quite honestly, it is really truly just being lazy. A convenience sample is just being lazy. Simple random sample gives you a very good random sample, while as a convenience sample, these are chosen. The simple random sample uses good sampling techniques to get a random sample. This is chosen by convenience. Convenience. All of a sudden I can't spell convenience. IENCE. It's convenience. That's it. Convenience, chosen by convenience. Sorry, I told you to read. So, simple random samples give you good sampling techniques, and you get a really, truly random sample. Convenience says you're going to take data that's already there, and it's really easy to get at. I always say it's like that. If it's on the internet, it has to be true. Oh, I found it on the internet, so it really has to be true. All right, let's check this out. The students in your statistics class are seated in 4 rows of 6 students. That's 24 students. To select a sample, you toss a coin. If it comes up head, you choose the 12 people sitting in the front. If it comes up tails, you choose the 12 people sitting in the back. In the last 2 rows. Last. Does every student have an equal chance of being selected for the sample? And the answer is yes. It's random whether or not it's going to be a 1 or a 2. Basically, half the class is 1s and half the class is 2s, but everybody has an equal chance of being selected. Is it a simple random sample? No. No, it is not. And I'm just going to say it, although each group of 12 has an equal chance of being selected, it's only two groups have an equal. So if you're in group 1, you have no chance of being selected because they selected 2. So it's not a simple random sample. It's basically striation, right? You broke them up into groups and then you picked one of the 2. It's not stratification. Sorry about that. It's just a weird way of picking. Instagram is trying to pick new features that filters negative comments off your feed. They're testing it by giving it to people with the most followers, like Taylor Swift and Mr. Krause. Oh, wait, not me. What type of sampling is this? This would be convenience. Convenience sampling. I'm just going to pick it because it's convenient to pick Taylor Swift. I'm not going to do any random sampling. I'm just going to pick Taylor Swift and Justin Bieber's. Because it's convenient. Give me good data. Give me a lot of data. How could Instagram get a better representation of population? I would say the best way to do it would be a stratified solution, which is to say we'll break it up into, age groups. I want the 10 to 15. I want the 15 to 20. I want the 20 to 25 year olds. I want the 25 or the 26, I should be saying. This should be 21. This should be 16. The 26 to 30 years old. The 31 to 35 years old. Or whatever. I want you to stratify it so we get a segment of every population. Maybe it's a little bit simpler than that. Maybe I just want, 11 to 12, 11 to 20, 21 to 30, 31. And then we're going to break it up into groups. And then we'll pick a sample from each group, a random sample from each group, and then I can see then I can use my test to see if I can figure out how to get negative comments off my feed. I have no negative comments. They just have to ask me. I don't have any comments either. Why are they using people with the most followers? Why do you think they would use the people with the most followers? Well, people that have a lot of followers have a lot of haters. Right? If you got a lot of followers, you got a lot of haters, which means you have a lot of comments, which means you have a lot to pick from. And you can get a lot of information back. If they asked only people between 71 and 80 how they can better create a filter that gets rid of negative comments off my Instagram feed, 71 and 80-year-olds might say, what in the world is Instagram? Or they might say, I don't have any, my grandkids love me, and they put up nothing but nice things on my Instagram feed, I think. But if you ask celebrities, and maybe what we do is we stratify celebrities into different age groups, maybe different sex, gender types, or whatever, and we stratify them, and maybe we stratify celebrities, anybody that's in the public eye, into age groups, and then ask them how we can get rid of negative comments. We might get a better feed. But if you're asking people that don't have any followers and don't have any negative comments, you're not really going to get any rich data back. So they're asking people with a lot of followers because you can really get a lot of data and a lot of information back, right? Nobody's asking, I don't know, the Pope, how he gets rid of his feed, his negative feeds. First of all, he's got people that does it for him. And second of all, I doubt very many people in the United States or in the world, anywhere in the world, are going to put negative comments on the popes. They don't want the wrath of later on in life. All right. That's it. I hope you're starting to get a better picture on statistics. You're getting a better understanding on collecting data, how to collect data, how to use random sampling. There'll be some homework on how to use the random number generator, as well as the random number table. Random number tables are probably the most used because not everybody has technology, and they're very accessible and very easy. Not only that, I can test them quickly, right? I can say, I want you all to start at 78 and pick all the numbers starting at 78. Well, you're all going to have the same numbers then. If I just say do something randomly and I have 100 students, that means I have 100 different problems to select. So a lot of teachers will use random number tables because they get a consistent answers on their tests. Okay. Anyway, if you have any questions, let me know. Hit the subscribe button, hit the like button, and tell me how much you like my haircut. I straightened it this morning. It's awesome. Bye.